is defined to be taking any function that you're given, evaluating it at x plus h, evaluating it at x and doing a subtraction, and dividing by h. So we're going to talk about where this comes from and why it's important in calculus, but for now we're just talking about how do we actually do that, how do we apply that. Given this function x squared, our difference quotient doesn't matter what the function is, the denominator of our difference quotient is going to be called h. And the function that we're given is always going to go right here because that's where f of x is in our difference quotient. But what we've got to do is be very careful about the first piece of that difference quotient, the first piece of the numerator. If we are going to evaluate our function at x plus h, that means that x plus h goes into our function where the x is. So since our function in this case is a square, we're going to take that x plus h and we're going to square all of it. Because our function takes whatever you give it and squares it. It doesn't take the x and square it and then add on an h. It takes that entire quantity of x plus h and it squares it. So you have to remember when you square x plus h, that means you are actually multiplying it by itself. And that means you have to FOIL. So when you FOIL this out, you're going to get an x times an x, which is an x squared, an x times an h, and an h times an x. But because of the commutative property, they're both xh. So you're going to end up with two xh's and an h squared. X times h times x, h times h. And then you're going to subtract away your x squared because that's part of the difference quotient. And when we come down to x squared and negative x squared adding to 0, we're going to call this 2xh plus h squared over h. And then you're going to remember from Math 21 that if you have a common factor, you should factor it out. And then once it's factored out, since this is connected by multiplication, you could divide away those two h's. Not this h because it's connected with addition, but you can divide away these two and come to your final answer. The difference quotient for the function x squared simplifies to 2x plus h. And finally, if we do the difference quotient on 1 over x plus 2, we're going to end up with an h on the bottom, because that's always there. The function 1 over x plus 2 goes there. And the first piece of the difference quotient is this function done on x plus h. So if I put x plus h in here, I'm putting x plus h in here. The x that was there is getting replaced with x plus h. So what that looks like is 1 over x plus h plus 2. So that's how to set up the difference quotient, but we have to simplify it because now we've got fractions inside of fractions, which is not simplified. So we're going to use the rule a over b minus c over d. You can multiply the denominators, b times d, multiply first numerator times second denominator minus second numerator times first denominator, and end up with the rule that we had on the previous page. What that's going to look like here is I'm going to multiply x plus h plus 2 times x plus 2. So this denominator times that denominator. There's no way to get a common denominator for these two any other way. It seems like you should be able to because they're sort of alike, but they don't have any common factors. So we're going to have to multiply them together and make it look like this. And then we're going to take this numerator times that denominator and subtract this numerator times that denominator. And I put parentheses around it because when you subtract polynomials, you have to remember you're subtracting everything from the second polynomial. You're subtracting x, you're subtracting h, you're subtracting 2. And if you don't put parentheses around, you might forget that. So we're going to have x plus h minus x minus h minus 2. And that's all over the two denominators multiplied together, and that's all over h. So now we're in that 3-story building situation, like we had 2 over 7 over 3, and we sort of collapsed it together and got 2 over 21. Same thing we're going to do here. We're going to collapse our two bottom levels together. And our numerator is going to stay our numerator. But there's a lot of inverses going on in that numerator. We've got x's that add to 0 and h's that add to 0. So in the end, we only have a negative 2 left there. And then we're going to collapse, and we're going to have our h and our x plus h plus 2 and our x plus 2. And that's going to be our difference quotient when we simplify it. So let's see, okay, so there are the two examples of how we're going to deal with a difference quotient. And that should be enough for you to get through your section point 1, point 2, and point 3 stat labs, which we're going to be taking a look at when we get together on Wednesday.